Okay, now in this one, we are being asked to use the graph, and we did this earlier in these notes where we had to look at a graph and find values, and we had to add them together, and we got separate ones. Okay, now in this case, we are doing composition, okay? So what this means is, again, remember that this means that you're going to take the g of -1, then you're going to use that value that you get here to find the f function. The first thing we need to do is we have to find g of -1. Find the y value of g when x is -1. We go to x is -1. We go to g straight up, and it is, I'm going to go with 1 here. That makes it a little bit easier. So this means that we now need to find f of 1, okay? Well, that means that I need to go to where x is 1, and what is f there? That equals 0. Okay, again, g of f of 2. All right, so first we need to find f of 2, then figure out the g of that. F of 2, go to x equals 2, f is 1. That means we need to find g of 1. So I go to 1, I go up to g, and it is 2.5. 2.5. All right, now we're going to go to here. Be careful, they already tell you it's a trick question. So we need to find f of g of 3. First, we find g of 3. 1, 2, 3. G of 3 is 4. Okay? So that just means that we need to find f of 4. Okay? 1, 2, 3. We don't have a 4. What do you think f is going to be? What value could you get there? Well, it's not there. You could say it's undefined. We could say that there's not enough room on the graph, and we can't tell from the picture. We don't know what the equation of the line is. We could do a variety of things. And so basically you cannot answer. Okay. All right. Domains of composition of functions. Domain is always tricky. Okay. First thing you need to do to find the domain of a composition, okay, you have to use this 3-step process. Okay, number 1, you have to find the domain set of legal inputs for G. That's the inside one. Okay, you always find that first. What is the domain for this? Then find the outputs from the G that are not legal inputs of F. So, what are the results that are not legal to put into there? Find the values of the x's that are inputs to G to create that output. Eliminate those values from x from the domain of G to get the domain of f of G. When you compose two functions, it is important to specify the domain of the composition using this method. Because if you just get to a formula and do not use this process, you might get an incorrect answer. All right. So, I don't know if this refers to example 5 or not, but we are going to do this one. Here we go. Number 1, you've got f of x is x squared minus 9, and g of x is 9 minus x squared, and they want you to find the domain of f of g of x. Okay, so first, what is the domain of g? If we graph this on our calculator, they tell us that the domain is -3 to 3, but let's take a look at that and just see, what they're talking about. Okay, we have the square root, and we have 9 minus x squared. And I'm going to graph that. We get a half a circle there. We get a little semicircle. And if I go to my table, I also see that sure enough, it touches there at -3, pretty symmetrical, and at 3. And so the domain is from -3 to 3. Okay? All output values from G are legal inputs to F. What that means is all of these values, when I get a value from there, that they are going to work in there. Therefore, the domain of f of g of x is this domain right here. It is the restricted domain between -3 and 3. Now, had we found the formula for f of g of x like they say right here, that would have looked like this. F g of x is the square root of 9 minus x squared. If I put that into the f function, I get the square root of 9 minus x squared, quantity squared minus 9. Well, that is squaring the square root cancels it. 9 minus x squared minus 9, which equals negative x squared. Well, the domain on that is all real numbers. So you can see that what's going to happen is you'll get kind of a mess there. So you have to go with the least restrictive. All right, in the next example, we have we've got a denominator, and then we have another square root. Find the domain. First thing you need to do is find the domain of g, this one. All right, you cannot have a negative under the square root. What that means is that x has to be greater than or equal to 100 in order to work. But what g has an output, g of x, this cannot equal 0. Okay? So, you cannot have g of x equal to 0 when x is 100. All right. So, x equals 100 cannot be in the domain. Because if it were, and we put it there, you would get a 0 in the denominator, and that does not work. Okay? Here, the domain is 100 to infinity. And you include 100. But for the composition right here, it goes from 100 to infinity and so on. And again, if you had done this formula, we would have gotten this, and you would think that the domain is everything except 100. All right, all set to do your homework.